All right, so in this first lesson, we will create our interactable interface, and we're also going to create two actors to interact with. A pickup item, where you can pick up an item in the world, and a door that you can open and close by interacting with it. But most importantly, in this lesson, I will show you why interfaces are important and what happens when we don't use them. So if you still don't fully grasp the idea behind interfaces and how to use them, then this lesson will help you a lot. And if you haven't seen part 1 of this series, which is just a very short video where I introduce what we'll be building throughout the entire series, make sure to check that out first to understand what the end goal is. And also, if you're interested, you can download the full project files with the end product already on my Patreon page, link in the description, as well as right here on the screen. Now, let's get started. All right, so I'm starting here with the third-person template, but before creating the interface, I want to create the actors that we will interact with. So I'm going to create a folder, call it the Interactables, and let's start by creating our first blueprint of type actor. And that is going to be our pickup item. So that's going to be the item that we will pick up. And I will create another one, actor, and call this one BP_door. So let's open one of them up, starting with the pickup item. And it's going to be very simple. We're just going to have a static mesh here. And this is going to be whatever item we're going to pick up. So I already have a sword static mesh. You can, of course, use whatever you want here. And we also want a sphere collision. This is going to be the radius where when the player enters, they can interact now with this item. So let's make it something like 100. So if the player is anywhere within this radius, they can pick up the item. Excellent. And we're going to do the exact same thing for the door. Door static mesh. Let's call this the door. And I think this door mesh comes by default with the starter content. And then also the sphere collision. And let's move it somewhere here. And also set it to 100. Yep, I think this is about a good radius to interact with the door. Right, so now at this point you might be wondering, why do we have two separate actors that both have static mesh and a sphere, but they don't inherit from the same parent class? And they're not of type interactable or something like that. Well, this is because we don't want to have a single parent class that all interactables inherit from. Because maybe you want to have an NPC that you can interact with, and that NPC will be of type character. So you can't have it inherit from a base interactable class. So inheritance limits your options here. That's why we're going to be using interfaces. But before we use the interface, I'm going to implement the interact function without it and show you what happens when we don't use an interface. All right, now we have two separate actors that we want to interact with, and we want different things to happen when we interact with them. So in the event graph of my pickup item here, let's get rid of all of this, and I'm just going to implement a single custom event and call it interact. Now this is what happens when a player, or really anyone, interacts with the pickup item. So here you'd want to add the item to their inventory and then maybe play a sound and destroy it. So to add, of course, we don't have an inventory, but if you did, you'd probably want to know who's interacting with you right now to add this item to their inventory. So then this needs to take an input, the interactor, the actor that is currently interacting with this item. So it's going to be an actor object reference. So of course, if we did have an inventory system, we'd probably get the inventory system from here and then call add to, get inventory and then add to inventory or something like that. But we don't, so we probably just want to print something here. So I'm going to print, and let me show you this neat trick. Let's say I want to print something with a variable inside it. So I'm going to search for format text, and then I can write something like added item name. This is between curly brackets, to the inventory of actor name. So anything I write between curly brackets now becomes a variable. So this will be the result that I print. And then the item name, I can get a reference to self, which is this pickup item, and say get display name. And then the interactor, I can get their display name and plug that in. So I was going to say something like added pickup item to the inventory of third person character, something like that. All right, then we're just going to play a sound. So play sound at location. And I'm going to use this VR click 3 sound. Sounds like this. And I'm just going to say get actor location. This is where we play the sound. And finally, the items have been added to the inventory. Sound has played. Then we can destroy the actor. All right, so we've implemented an interact event for the pickup item. Now let's do the same for the door. Now, obviously, interacting with the door does something completely different. So let's also go here, create a custom event, call it interact as well. And now what we want is to open and close the door. Well, open it if it's closed and close it if it's open. So we'll need a variable called isOpen. It's a Boolean to tell us whether the door is currently open or closed. And we need two custom events, one to open the door and one to close it. So open door, and I'm going to duplicate that, close door. And of course, open door sets isOpen to true, and close door sets isOpen to false, and then open and close the door. But before we do that, let's implement the interact function itself. And it's going to be very simple. Just going to do a branch and check if isOpen, then close door. And if it is not open, so this is false, then open the door. And that's basically our interact function. Now I'll implement the opening and closing of the door. And if you don't care really how to implement this opening and closing of the door smoothly, you can skip to the timestamp you see on the screen. Otherwise, I just add a timeline, and timeline is what allows you to do things over time. So I'll call this the open door timeline. And I'm going to double click it to open it up. And the length here is how long I want this to take. So let's say the door opens in 0.7 seconds. And we're going to add a float track. So this is the value we're modifying. So we're going to modify the Z rotation of the door. So I'm just going to give it the name Z rotation. Then I'm going to right click here, add a key to the curve float. So this is a time and a value. At time 0, the value of the Z rotation will be 0. Then right click, add a new key. At time 0.7, so at the end of this timeline, the value will be 90. Because basically that's how you open the door. You rotate it 90 degrees on the z-axis. But we're doing this over time, so it's going to be smooth. And then here, now we have a pin called z-rotation, or whatever we named it. So I'm going to get my door. I am going to set relative rotation. And then right click and split it, because I only want to change the z value. And on update, this is what I'll do. So then this will automatically set my relative rotation from 0 to 90 smoothly over time. And closing the door is very simple. We just plug it in the reverse. So go from 90 to 0. And that's pretty much it. And we can test this by doing an on begin play. Let's do wait 1 second and then open the door, and then wait another second, and then close the door. So let's see how this looks like if we take our door and put it in the level here, and play, opens, closes. Perfect. So we can delete this because it was just for testing. All right, now we have two interactable actors, each with their own unique implementation of the interact function. Now it's time to go to the player blueprint and actually interact with these actors. All right, so this is the third person template. So the player character is inside third person, blueprints, and BP third person character. So the first thing we need to do to be able to interact with something is know what are the things that are in range that we can interact with. So we're going to keep track of them by creating a variable here and call it interactables in range. And this is going to be of type actor. But we're going to change it on the top right here from single to array. That means we just want a list of actors because there can be multiple interactables within range. And whenever something comes into range, we add it to this array, and when it leaves, we remove it from the array. So to know when something comes in and out of range, we're going to click on our capsule component. So this is the actual collision of the player. And then on the details panel, scroll down here and add two events for onComponent begin overlap. Click it again, and onComponent end overlap. So this is when something overlaps with the capsule and something stops overlapping with the capsule. Now, the problem here is that this is just an actor. I don't know what I'm overlapping with. Is it something I can interact with or not? And here is when interfaces become essential. Because right now, for me to know if I should add this to my array of interactables in range, I have to do a branch and first check. Is this actor get its class first? And then check, is this class equal to one of the interactables that I know? So is it equal to PickUpItem? And if it's not, well, is it equal to something else? Is this class equal to door? And so on. So you see, this is not gonna scale very much, and then I have to do this check also here again. And the more interactables I add, I have to do another check. Of course, I can do it also a different way, do it an OR. So is this equal to this, or equal to door? But it's not very clean, and it's going to be a lot of work. And not only that, but once we actually start to interact, so let's say on keyboard, just anything here, when I press the E key on the keyboard, let's say I want to get the first interactable in range, so get 0, and now I want to interact with this thing, but it's an actor, so I can't call interact on it. There is no function interact on an actor. This function only exists on my pickup and door. So I have to first cast it to pickup, and then I can call interact. But what if it's not a pickup item and the cast fails? Well, then I'm going to have to try again to cast it to door if the cast fails, and then interact with door. And as you can see, also this doesn't scale at all. I will have to do this for every single interactable that I add. This is why we need interfaces. So let's see how an interface solves this issue. It's important to know that an interface defines a structure for a class, but doesn't tell the class how to implement it. Meaning that the interactable interface, for example, will define that any object that implements the interface needs to have an interact function, and this interact function should take this as input and give this as output, but how the implementation of the function actually goes, that's up to the class to define. So now let's implement this interface and show you how it cleans up all of this mess. So I'm going to go into here and create a new folder and call it the interaction system. And inside here, I'm going to search for interface and click on blueprint interface and call it BPI for blueprint interface interactable. And then open this up. So here we define all the functions that an actor needs to implement to be considered an interactable. For now, the only thing that an actor needs to implement is an interact function. And that interact function needs to take one input, the interactor, so the person or actor interacting with an item, for our pickup case, and that's going to be an actor. And for now, this is it. We're going to add more in future videos, but right now, all we need is really an interact function. That's it. Then we need to implement this interface in our door and pickup. So going to the pickup, what we're going to do is simply just delete this interact function. And now what I want to do is go to class settings up here, and then under implemented interfaces, search for my BPI interactable. And as soon as I do that, I'm going to have a new tab on the left here called interfaces, and underneath it, one interact function or event. So I double click it, and it automatically implements or tells me to implement this function. And then everything here is going to be the same. All right, and we do the same thing for the door. So again, go to the door, delete this interact function, class settings, implemented interfaces, BPI interactable, and double click on the interact function. And I'm just going to plug it in here. And the interactor, we don't need to use it because the door doesn't care who is interacting with it. It just opens and closes and doesn't do anything else. Great. So how does this affect all of the mess that we have here then? Well, very simple. Right now I overlap with an actor and I want to know, is it an interactable or not? So to do that, there's only one single function that we need to call, and it's called just object implement interface. And then I'm going to give it the interactable interface. And it's going to tell me if this actor implements the interface or not. And if it does, then all I'm going to do is get my interactables in range, say add unique to add a unique item to this array, and I'm going to add this actor. And I'm going to copy all of this because on end overlap, so when something stops overlapping, we want to do the same thing. Does it implement the interface? Then instead of adding it to the array, we're just going to remove from the array. So remove this actor from the array. And if it's not in the array, this won't do anything, so that's fine. Great. So this is now very simple. We don't really need to check what the class is, and we don't need to do any casting. Now here is where things become really interesting. So I need to also call the interact function on the pickup item. I need to call the interact function of the door, but I'm not going to do any casting. I'm going to actually delete all of this. And all I'm going to do is get my first interactable in range. And now, even though this is still an actor, I can now call interact. And you'll see that now under BPI interactable, there is an interact function with message between brackets. And if you read the message here, it says, this does nothing if the target does not implement the required interface. So by default, it will check for me if the target implements the interface. It will call its unique interact function. So for the door, it will call this one. For the pickup item, it will call this one. And I don't really need to worry about what's being called here. All I need to do is just give it the information it needs. So the interactor here is myself. And that's it. So now the interact function is super simple and no need for casting. And by the way, if you don't know why casting is bad, I can show you a really quick example. Right now, if I look at my third-person character, I can look at its size map. This is what the size of this single class is on disk and on memory. So I can see that the memory size of a third-person character is about 105 megabytes. Now, I can change it if I just add a cast here. Cast to BP door. I don't even have to connect it to anything. As soon as I add a cast, and now if I check the size map, oh, I need to compile. Now if I check the size map, you'll see that it grew to 113 because everything, and here you see that the door is now part of the third-person character blueprint. Because when you cast to something, you're saying that this third-person character depends on the door class. So when this is loaded into memory, then load this as well, even if you don't connect it. So that's why usually casting is bad for memory usage, because you end up loading things into memory before you need them. But it's not bad if you always have an object in memory. So casting to something like the game instance or game state or these things are always loaded into memory. So it doesn't matter if you cast to them. All right, so that was a quick detour, and now back to our tutorial. So let's demo everything we have here. So I have my door, and I also want my pickup item here. So, and I'm gonna go play. If I press E, door opens, press it again, door closes, pickup item, nice. And it prints on top the print statement that we added. And we can also change its color just to make sure we see it. Make it like dark green-ish, and also make it last for, I don't know, 10 seconds. Now if you play, see, added BP pickup item to inventory of third-person character. Perfect. And this color is not readable at all. Okay. And we can also play a sound when we open and close the door. I'm just gonna play a sound at location. So when opening the door, get actor location. And I'm gonna use this enter simulate sound. And here I'm just gonna copy this. And I'm gonna use a different sound, leave simulate. Now let's see what this looks like. Very nice. All right, and this is the most basic form of our interaction system. All right, so to recap, we've implemented the BPI interactable interface that any actor can implement to become an interactable actor. And we implemented this interface in two actors, the PickUpItem and the door. Then in the player blueprint, we check if the actor enters the range of any interactable, and we add it to an array of interactable actors. And then when we press E on the keyboard, we get the first element from this array of interactable actors, and we call its interact function, which is an interface function. In next lesson, we will implement the player interaction component. This will be an actor component that holds all of the functionality needed to allow the player to interact with any object. So that means we will move the interactables in range, the collision check, the input, and a lot more things. We'll move them from the player blueprint that we've implemented in this lesson, and we're going to create a separate actor component that contains all of this functionality. And I will show you why doing it this way keeps our code clean, modular, and easy to reuse. And with that, thank you for watching, and I'll see you in the next lesson. How many times can you say interactable actor interface in a row? Interactable actor interface, interactable actor interface, interactable.